Apologies, we are just doing a final fine-tuning. I presume that thank you all for coming. We see people still coming into the room. We're going to start in 2 minutes. Olats, you're going to give us a sign? Your microphone is off.
Sorry, yes, tell me.
Okay. I think we are ready to start. Thank you all very much for coming. The webinar is organized by my colleague Olats Silva, and she's in charge of the DMaaST project here at the EEIP. Basically, I just would like to welcome people on behalf of Energy Efficiency and Industrial Processes here in Brussels and on behalf of the DMaaST project. Interestingly, at the EEIP, we have been working for, we exist for about 15 years. We were launched at the European Commission in 2011. And since the very beginning, we sort of like, we perceived, this need, to kind of like look at the energy efficiency and all this sort of like in this ecosystem. That 15 years ago, there was a lot of work we did on automation, we did on energy management systems, on the sensors and on the things, which sort of, from today's perspective, they seem like kind of like, the ancient history in manufacturing. But since then, what we, and at the time, which is important to say, we also looked at the energy efficiency at the factory level, at each individual manufacturing facility site. But very soon we realized the energy efficiency really does not make a sense when you look at the one individual factory, but it's something which is connected. And it's something which sort of encapsulates really more than one factory. So we have since, looked at, and worked on industrial symbiosis quite a lot, on IoT, on this, what they called Industry 4.0. We were partners at the Hanover Messe on Industry 4.0. And this was quite exciting time because they sort of like materialized these elements of connectivity in industrial energy transition. Now with the DMaaST project, we entered, into more sort of structured ways of looking into the manufacturing as a service. And look, basically the digital tools that can enable and sort of ensure more sustainable production when it comes, both on the individual sites, but also across the whole value chains. Interestingly, with this morning I was at the event which was organized by European Metals. And I had the opportunity. Obviously, these are the sectors which are the energy-intensive sectors. And I spoke to a few people, and I says, "What do you, when you hear about flexibility in manufacturing, how does it affect you at kind of like the high up the kind of manufacturing chain going to the raw materials?" And I was really told it's interesting to look how many are, for example, in copper industry, we have about 10. Smelters in Europe, and then when you have like a processing of the copper elements, you have kind of some hundreds of people. But when it comes to OEMs and manufacturing at the level which is more sort of B2B, but also consumer orientated, we have hundreds of thousands companies in Europe. And some of the technologies which have been developed, on the kind of scope, of the development in manufacturing, like 3D printing, they have advanced so much that that these days, specifically on copper, I was told, that you can kind of fine print elements from copper, which have 100% conductivity, which is not really the case with the kind of traditional manufacturing systems. So basically kind of this kind of fine grading and technological improvement, and then the connecting the manufacturing, it not just improves the flexibility, but improves also the speed of production. Another thing which I wanted to say is that with the manufacturing as a service, what we have, we have also this kind of human face, something which is really kind of, the people-orientated way to manufacture. So it's sort of materialized because very often in the energy efficiency, we have a problem, when we account, kind of energy improvements, that the only kind of bankability, comes, to kind of large things like electrical motors or pumps or energy management systems. And we very early realized that there are lots of elements which are kind of adjointed to the whole energy ecosystems in the businesses, is kind of people orientated or safety orientated, and in general they were called like these things non-energy benefits or multiple benefits. And with the manufacturing as a service, what it kind of unlocks, quite a lot of these kind of humane elements in manufacturing, and it kind of potentially makes the whole manufacturing process more bankable when it comes, and also economically efficient when it comes, really sort of when it includes, these multiple benefits, which are actually easier to monitorize through manufacturing as a service. So with not much more to say, and I would like, very much, to welcome our speakers, and I would like to thank again Olac, for organizing the webinar. Just on the note, for the questions, please put your questions in the chat or in the Q&A. We will be monitoring both of these. And then, we can have opportunity to discuss at the end of the webinar with our speakers. So without further ado, I would like to invite Damir Filipović, who I know for quite a long time, he was really in charge, here, in Brussels, on IoT, and, one of the kind of leaders on the modernization of the manufacturing. And I'm very much looking forward to your presentation, Damir. Thank you.
Thank you, Dušan. Thank you, everyone. Thanks for joining. So let's maybe go to the next slide immediately. So I'm here also, so I work for the BluSpecs, which is the consultancy in Madrid, in Spain, and we lead the project which is called CEI-Sphere. CEI means Cloud Edge IoT, and I will give you a bit of an overview about the project and why we are actually, why basically we use this framework to explain what I wanted to present today. And this project is a coordination of the two bigger projects, which are called large-scale pilots, because they are obviously testing a lot of pilots and use cases, including in manufacturing, but also in energy, mobility, and other domains, agriculture. And you see that these projects are quite big, for 3.5–4 years, worth about 30 million euros each. And the point on this project, of course, is to show a sort of the scalability, replicability, and then, of course, applicability of the solutions supported by the Cloud Edge IoT in Europe, in particular domains. And one of them, of course, will be manufacturing that I will try to basically explain a bit later. Let's go to the next one, please. So here, what we try to do with these two projects as a starting point is to group what they try to do in 3 domains. And you see that first domain is about energy and infrastructure resilience. Then the second part is mobility, logistics, software-defined vehicle. And then the third one is industrial optimization, productivity. And I will, of course, today focus on the third one. Although, of course, in what already Dušan mentioned, that with actually these two previously mentioned, there are also links, because, of course, if you talk anything about the mobility, we all know about the OEMs, manufacturing that they have, and all the improvements that we are hearing that the production of the new types of the vehicles have in Europe. But here we are focused really on the IoT-enabled manufacturing, robotic, predictive maintenance, digital twins, industrial data interoperability, and then AI edge intelligence for operational energy optimization. Not only, but this is, let's say, a kind of starting point for us. And why we are doing it? Because what we want to do is to identify and actually see what are the market challenges and opportunities that are basically particular for each of these verticals, and then provide continuous market feedback on the pilot deployment, so that basically they can iterate their solutions and bring it closer to the market and to the let's say demand fit at the moment. And how we are doing it, among other things, is of course organizing a lot of engagement with the various industrial I would say players, both the ones who are kind of producing and use, let's say, manufacturing, and also with users, because of course what they do. So for example, what Dušan mentioned, he said, we use, let's say, the 3D printing, of course, that's something that can be used. And of course, this you can get scale and speed with that. But for example, if you go to the domain that is now quite hot, so to say, for the industrial, let's say, purposes in Europe, and that's defense, what you are getting is not only speed and flexibility, you are getting also proximity. And what I mean by this is that now, with all these technologies that you have, provided that you have enough energy to do it on spot, you can take your basically 3D printer with you to the field and quickly replace by printing on spot actually the component that you need, right? So this is the type of the things that we are also kind of trying to take into account there. Let's go to the next one. And here, of course, I will not go like to talk you about this or that case. What I will explain is like what we are trying to also do in a broader sense of the ecosystem, let's say, building and understanding. And this is a model that we call the hourglass, where we try to map the stakeholders from the infrastructure providers to the applications, also to list their capabilities per each of the layer. And you see that there are basically 3 layers. The down layer, which is infrastructure basically, middle layer, which is about the platform and the tools, and then the upper layer which talks about the data and the applications. And then, of course, they have certain capabilities. They can use open source, and of course, there are involved standards there, which will be either through the information model profiles, MIM profiles, architecture patterns. And what we try to do is actually identify this and help also all the players in a way that they understand where they are, who is there in the ecosystem, how they can interact, and what they can use from actually what already exists in the market. I didn't put here, but there is, of course, another element. There are many elements. And again, this is an ecosystem approach. But one element is also regulatory one, because if we talk, what we will also hear from the other speakers about the role of AI, then immediately when there is an AI, there is an AI Act, like the European legislation that is coming there, and many things that are now in the process of definition, like, for example, high-risk models. And then the other thing is, of course, cybersecurity, because whenever something is related to the data, to the platforms, to access to data, interoperability, then, of course, cybersecurity, and then the relevant EU legislation is related to that as well. The next one, please. And of course, we are coming from the cloud edge IoT perspective here, but that's just an example. You can add AI, you can add whatever element you want there. Now for the manufacturing, how we try to do this, applied basically to the examples that we have in the 2 big projects that we are mentioning. You see that basically we are starting from the bottom part on the ecosystem, from the equipment, hardware, and component manufacturing. And then, of course, we are adding data and infrastructure, manufacturing operating systems, service providers, and then applications and end users at the end. And then on the capability side, you see that this goes from the physical assets, orchestration, platforms, cloud edge IoT assets, which basically we are talking here about reusable digital assets, models, and services. And point that we want to take from the project is that even if something is developed at the level of the pilot of the use case of that project, this hopefully and ideally can be recreated, reusable, rescalable as a digital asset in other similarly applicable cases. And this basically model should help everyone to identify these, let's call it building blocks, patterns, architectures, and then reuse them in their context rather than inventing or reinventing wheel. And also by this, I would say cut the time basically to understand what needs to be done, how to implement it, and which building blocks to use, which already actually exist, rather than reinventing the wheel. The next one, please. And this is basically for the industrial use cases that we have in these 2 projects, which are based first, of course, on the infrastructure providers, starting with the connectivity, Internet of Things. And you see basically also that this is not just sensors, there are also drones, robotics, general connectivity, asset tracking, and so on. Then we go to the infrastructure service providers, which are building this to the level of the digital twins and various simulations and processing at the edge. Then we have the next layer built to the platform and tool providers. And then, of course, you have a certain orchestration there. And then it goes to the data space, build up with the data space analytics, various modeling, and then optimization. And then, of course, last but not least, it comes to the application developers, and then to the various direct applications and end usages. And then you see that we have some of the examples that are covered in these two projects, like mining operations dashboard that will be developed in one of the projects, winery production monitoring, and the third one is a smart factory control center. This is just kind of examples that we found and that we have that are directly related to industry. Of course, we have developed this for actually every use case that were done in both projects, which is almost about 50 of them. So we have this kind of, let's call it analytics developed for each of them. And I think this is hopefully useful because everyone can, from these examples, again, identify what are the building blocks, what is reusable, what is scalable, what is the pattern, and then apply this into building their solution, which I think can help with this reuse. We believe that actually in Europe we can get faster to the market and to the solutions rather than inventing and reinventing wheel every time we start to do something. I think that was the last one, if I'm not mistaken. Yes, and this is just kind of if you would like to get in touch, please feel free, and then we can have other separate discussions if you are interested to find out more, or if you would like to see how this would work in your particular case, we can help you with that, and then also continue working with our spheres, because we are having the various expert workshops in which we would like to engage with the end users and with the practitioners to see basically what of this would be useful for them and how the ecosystem works in their case. Thank you very much.
Thank you, Damir. I think there was a great presentation, and what you said, something is quite interesting about this sort of, the resilience or the proximity of what you meant, for the 3D printing, because I mean, here in Brussels, we had a lot. I'm talking because my colleague is trying to fix, the technical issues for the next speaker. But what we have, in Brussels, as we had lots of these discussions on competitiveness, and the changes in the manufacturing, which improves, the general competitiveness. But this has, in the last, I would say, like year, has also changed, to this kind of industrial resilience, and definitely. The manufacturing as a service and what you presented as your project, it's definitely something that kind of enforces this resilience of European manufacturing, because we do not really need to have these big factories, which are usually kind of 100-year projects. We can really have manufacturing, at the point of need or at the point of delivery, and we can have it, very much sort of dispersed. I'm seeing, really, I don't know, Olac, have you managed to connect the next speaker, Branimir Rakić?
I did give him access. I'm not sure if he can now open his mic. I'm guessing if he doesn't reply, that's no.
He said no. Okay, who is the speaker after that? And maybe we can move down the program and then we can come back to Branimir. After
Sebastian is the next one.
Okay, so let's hear from Sebastian, and then hopefully in the meantime, we'll manage to fix the technical issues with Branimir. I mean, it's crazy, we have a kind of program and event here, on the digital things, and we're sort of still struggling, with some of these. But it's all the excitement of the webinars. Thank you so much for your patience, and Sebastian, the floor is yours.
Thank you very much, Dušan and Olac, for the invitation. And good afternoon, everybody. So I'm Sebastian Pena Serna from clesgo, and I would like to talk today about the MaaSAI project, which is also a manufacturing and a service project that started in 2024, by the end of 2024. Next slide, please. So MaaSAI started because we have understood that manufacturing is being challenged since the last, let's say, about 2 decades, especially here in Europe. We have seen that, it is getting more difficult, things are getting more expensive. At that point in time, outsourcing was very relevant or very, very used. And now we are seeing part of the consequences of that. The countries we were outsourcing the production to, now they have the knowledge, the technology, and they are getting to produce what Europe is doing. And on the other hand, although Europe has still a lot of potential, a lot of innovation, a lot of creative people, what we have seen also is that not all the companies have access to the same amount of resources, whether there are modern manufacturing equipment, digital solutions, or also the possibility to collaborate with other companies. And this has been especially critical if you see that in the context of manufacturing SMEs. So manufacturing SMEs are 99% of the European manufacturing industry. They employ 2.1 million, they are 2.1 million enterprises out of 2.17 or something like that, if I remember correctly. So they are very important for manufacturing in Europe, but if they are challenged, then they will have difficulties to produce and especially to be resilient, to keep up the employment and to be sustainable, as Dušan was explaining before, also to keep the competitiveness inside Europe and outside Europe as well. Next slide, please. So based on that, MaaSAI as a project, we wanted to somehow handle and tackle these challenges and try to understand how we democratize the access to resources. And we are not only talking about manufacturing equipment, but also other kind of resources like services, data, and how to connect those resources from mass providers and with mass consumers through an interface, through a platform that will support them in, let's say, speed up, accelerate, and actually complement the capabilities that they have inside a B2B ecosystem. So what MaaSAI is offering is, on the one hand, we have a cloud interface that is connecting all together, mass providers and mass consumers, but it is not only limited to that. We also are developing dedicated tools for providers and for consumers in order to help them, on the one hand, digitalize their production processes, especially for providers, and for manufacturing and service consumers, that they are able to reschedule, resimulate their supply chains by accounting or by including the remote capacity that they will be able to access through the MaaSAI system. Next slide, please. So the key benefits that we see inside MaaSAI, on the one hand, is reduce of the cost. So we know that buying new equipment is very expensive. So for that, you will need a big investment upfront, and then you need to figure out whether the return on the invest will work out or for how long. So what we have seen also in the last 10 to 15 years about the share economy is somehow now entering into manufacturing, and that is helping us democratize the access to advanced manufacturing machines that are owned by other companies, but are not always busy, which means that they are not producing, they could, as a provider of such manufacturing resource, they can benefit by allowing somebody else, a third party, to use their resources. And as a manufacturing consumer, they will be able to complement their manufacturing process, perhaps with some advanced manufacturing equipment, perhaps with additional kind of processes that they didn't have in place. And in that case, still being innovative, but without the need to make this big investment. On the other hand, we also are very focused on sustainability and in how to improve sustainability. So inside the project, we have different tools that are trying to access this and are trying to understand what is the waste, what is the energy consumption, how to analyze what is happening inside the factory, and how to guide the manufacturers in such a way that they can take informed decisions about how to improve their sustainability, and of course, how to represent that inside, for instance, the digital product passport. Enhanced collaboration is also an important aspect, especially in the context of bringing together different parties, in this case, mass consumers and mass providers. So trying to build a virtual network that will help you to improve your processes and generate additional value. And finally, this webinar is about flexibility in manufacturing, and I will try to address that later on. But production flexibility in terms of scaling up or down your needs according to your requirements, according to the order that you are receiving, is also an added value that we see that MaaSAI is able to deliver. Next slide, please. So what is the approach of MaaSAI? So on the one hand, we want to understand the manufacturing life cycle. We want to understand how to support it, and we want to be able to offer the different parties that we are supporting different tools to go and to improve that. Automation is also a very important aspect. So in the context of MaaSAI, we are using in very different areas AI, but especially we are working about, or we are developing AI agents that are focusing on facilitating the negotiation between consumers and providers, and in that way, improve that process and speed up that process so that you are able as a consumer to find the best possible provider without the burden of having to do that on an individual basis. You will have some autonomous agents doing that for you. Of course, at the end of the day, you as a mass consumer will be the one taking the decision. And finally, the integration and the collaboration. So you have a platform where everybody is coming together, where you will be able to share knowledge to improve your processes and benefit from this collective intelligence. Next slide, please. So the proposition of MaaSAI is, we are building this manufacturing as a service ecosystem. As I said, we have, let's say, upper level, a central platform that is bringing all the actors together. But then we have dedicated tools for consumers and for providers, very tailored and designed for their specific needs. So as I mentioned from the beginning, we are talking about mass consumers and mass providers, and the autonomous agents are part of this important step, especially bringing together in an efficient manner the consumers and the providers based on the needs that one has and the capabilities that the other has. Next slide, please. And in terms of the dedicated tools that we have, so we are trying to cover as much as possible. So from the side of the consumer, we have, of course, the possibility to have control panels to remotely monitor what the third party is producing for you. We have the supply chain simulator that will allow you to redefine or adapt your manufacturing process or simulate your manufacturing process now, considering these remote resources. If we go on the side of the provider, then we will have the digital twin designer, where you will be able to build your own digital twin for your own manufacturing process. You will have prediction maintenance toolkit, LCA and LCC analysis. We have the digital product passport designer as well, because it is important that for every product that is being produced, or for every part that is being produced, that the associated DVP is being able to deliver. And we have other tools that facilitate that communication. Very important from the point of view of MaaSAI. On the cloud, we only have that general interaction between or among consumers and providers. But when we go into the factories, the consumer factory or the provider factory, those tools are being deployed locally. None of the data are going outside their factories. So the only thing that we use or that we leverage in the context of the cloud area is just the connection. And for that, we need information about the capacities or information about the requirements for the consumer. But the other information like process data, machine data, sensor data, that is just handled locally. And of course, you will have the tools to generate more value out of that data, but that data will never leave your premises. Next slide, please. So MaaSAI is now at month 18. The project is running for 36 months, so we are more or less in the middle of the project. We have already developed all the first versions of all the solutions that I have been trying to address before. We have about 23 solutions. And now the next step is about deploying all these solutions into the pilot. Next slide, please. So we have 5 different pilots in Spain, Italy, Greece, and Finland. Yeah. And Portugal, sorry, I was missing one. And those different factories or pilots are covering different aspects of the manufacturing process, and that will allow us to validate the tool, the MaaSAI system, and to understand how to be generic for all different requirements and different perspectives that the pilots are bringing into the project. Next slide, please. And just to finalize my talk, so since this was about flexibility in manufacturing, I tried to summarize what I was explaining or what I was talking about before and try to put it into these 4 different areas: flexibility in technology, flexibility in production, flexibility in circularity, and flexibility in business. So, of course, MaaSAI is about democratization, the access to remote resources. However, behind that, what we are actually enabling is improving competitiveness, improving resilience, increasing potentially employment, and of course, all of that is very related to flexibility. So if we try to phrase that in the context of flexibility, from the point of view of the technology, we have multiple tools that can be used as needed, can be locally used, and that will help all of the factories to digitalize and be, in that way, more flexible in order to be able to react or to adapt to new demands, to new requirements. From the point of view of production, as I was mentioning before, especially for SMEs and for mass consumers, having the possibility to access external capacities that they don't have, external services that they don't have, that will allow them to actually create more or be more creative in the products that they are designing, that they are creating, and then manufacture them by complementing those with other capacities. And that flexibility from the point of view of designing and creativity is also an important aspect for being competitive and resilient. From the point of view of circularity, we try to address that very seriously, and we try to offer the different tools to the providers and the consumer in such a way that they can take informed decisions and they can take action based on those decisions, analyze the life cycle, and of course, all of that will depend on their individual needs as well as the current requirement that they are receiving. And finally, from the point of view of the business, so as I was mentioning before, you are kind of building a virtually endless network of trusted partners with whom you will be able to cooperate. You will be able to cooperate faster through these autonomous agents. And at the end of the day, also record this transaction in a smart contract and a blockchain, helping to be transparent and to generate a trusted environment for all the involved parties. So that was all from my side. Thanks a lot.
Thank you, Sebastian. I mean, it's very encouraging to see how you enforcing the messages, we had, with the Damir's presentation as well, and in bringing in, not just the networking and digital twins, but also the sort of the opportunities, that we have in manufacturing as a service. I mean, you have the opportunities that are endless, which sounds, very good as a catchphrase. So, thank you very much for your patience, and we are happy to say that we would like to have now to have a Branimir Rakić to carry on his presentation. And again, not further anything to say. Hopefully, Branimir, we can hear you, we can see you, and apologies, for any technical glitches we had so far. Thank you.
Thanks, Dušan. Hi, everybody. I blame it on Microsoft personally. We should switch to something European for these type of calls, in my opinion. Anyways, puns on side. Thanks, everybody. Great webinar so far. I'm here to present what we've been building with the DMaaST project. Just as a short intro, I'm co-founder and CTO of Trace Labs. We have been building something called the Decentralized Knowledge Graph, or OriginTrail, for over 13 years now. So I'm here also in that role. And I assume I just say next slide when the time comes. So yeah, there we go. Next slide. I want to make the case that flexibility is actually the speed of shared understanding. It's a function of shared understanding. And that's something that we're tackling with the DMaaST project in something we are building, which is called a smart manufacturing platform. We're building it on OriginTrail, the technology we have been pursuing for these many years, as I mentioned. And I'll try to give a very short recap and to hopefully give it justice in these 10 minutes. So please, let's go to the next slide. Let's imagine a scenario. 6 in the morning, your supplier is out, is no longer supplying the important part that you need. And that was the only supplier. So what do? Then now the presentation expects a few clicks. So basically, we need to know which parts have been single sourced from this supplier. Are there any alternatives? Can we expedite it? Who can expedite it? Who's the person in our company that can do this? And which orders are at risk? How do we handle that? Can we prioritize? Who do we prioritize? A lot of context that you need immediately, and it's an emergency, right? And usually a lot of this information, most of the time, doesn't live inside of the walls of one company. And even if it does, it's scattered. So can we go to the next slide, please? Where is it scattered? And just please open up the slide to the end, because this I guess works better when I click. But what I'm trying to say is basically we have the need to understand the situation, and the faster we can understand it, the more flexible we can be. Any of the shown issues, such as supply shocks, demand swings, can be such events that require extreme flexibility. And the flexibility doesn't mean having more stock or having more machines that are just sitting idle for these types of events. It's really about how fast you can adapt, right? And how fast you can understand the situation, you can act. So basically, you need to process a bunch of scattered information. And that information sits in different servers, in ERP systems, sometimes in heads of people. So it's really a question of how do you get to all of it together. And in my opinion, flexibility is a function of context and the speed of that understanding. So let's go to the next slide, please. So basically, we have three problems, three walls that are behind us and that in front of us, and that answer in between us and the answer. Number one is that data. So the data sits around, like I mentioned, all over the place. Number two is it's a question of control. Who controls the data? Is that data within our company, or is it outside? Do we need to somehow find the right key to get the access to that data? So who's really governing that access? And last but not least, the third problem is really a problem of trust. Can we trust that data? And can we, with this new beautiful world of empowerment by artificial intelligence, can we trust artificial intelligence to perhaps act on some of that data? What does that trust require? So I'll try to explain how we tackle these three problems through the DMaaST project. Next slide, please. The system, and yes, please open it, thank you. The system behind DMaaST is actually being developed by 12 partners in 10 countries. We have two demo cases, and a sizable budget. And what we really try to achieve here is to focus on manufacturing and value networks, make them resilient, make them flexible. So several sub-objectives that are being tackled within the project are data interoperability. As I mentioned, we're trying to get data from different sources. We need to somehow get it interoperable. And that's where we tackle this problem with the decentralized knowledge graph, the technology we've been building at Trace Labs. Number two, we're on top of that building a layer of cognitive digital twins. So essentially creating digital twins of literally factories and value chains, so that we can simulate potential disturbances and events, as well as analyze what's going on within those. Finally, there's multi-objective decision support system that is built on top of that, on top of those two, so the interoperable data and the cognitive digital twins. And obviously that is there to help us respond to such events that require either some sort of flexible activity or a threat. Ultimately, we're trying to obviously improve efficiencies, but also sustainability and circularity. So there's a specific module for that as well. So that's a very, very brief overview of DMaaST project. And on the next slide, we'll see that a little bit more graphically. So if you think about DMaaST as a multi-layered project, you can think of it like this. At the bottom, we have this knowledge graph, the decentralized knowledge graph. I'll explain in a moment what it is, but essentially data that is interoperable, organized well in a graph according to well-adopted ontologies, on top of which we build the value chain digital twins, the cognitive digital twins, on top of which the layer of multi-objective decision support system lands, leveraging the layers below, and finally coming up with the human-centric interfaces, which today are both the, let's say, more traditional UIs, as well as agentic interfaces. So those both fall under this top layer. Moving on to the next slide, I'll try to explain how we tackle these problems individually. So the problem of dead data, as we called it, is being tackled in the project with what we call a living memory. So the idea here being is that memory is the overarching paradigm where agents, which are the users of the future mostly, but also users of today, are able to basically tap into all this information. And to do so, we are leveraging, as I said, OriginTrail decentralized knowledge graph. Essentially, this system allows you to create graph resources based on RDF and W3C standards and discover those across different machines, different systems. So the data doesn't have to sit centrally in one place. That could be like, let's say, natural solution to the scattered data problem, kind of a relatively naive one, but the one that doesn't work. I'll explain why it doesn't work in a moment. But just to finish on the first one, ontologies are helping to organize that data. So it's not just data, it has meaning attached to it, and that meaning is machine readable, it's well structured. And the relationship themselves are basically the data. So that's something that we grow from just raw data and tables. We get into something that has semantics. And ultimately, that becomes really great memory for agents. So agents, turns out agents are loving graphs. And I can share some numbers. We've actually tested coding agents using graphs as memory versus markdown files. They get 60% cheaper in terms of tokens used for LLMs and 40% faster. And I'm talking about multiple agent scenario. So just because they can retrieve easier and get their way around the graph, traversing it obviously much easier than using some sort of linear search or cosine similarity type of search, which is great, but is not awesome for more generic use cases. So number one is we apply the graphs, and what comes as this prefix of decentralized is what tackles the problem of control. So the whole point of why we're doing this on the DKG is because everybody gets the ability to keep ownership of their data. So instead of one central shared database, we have nodes that are running across the globe on servers or even laptops on the edge, where basically data can reside and can be addressed and discovered. So that is the key power of the decentralized knowledge graph. So nobody owns the entire system. It's all open source, by the way, and built on standards. And it's designed so that whoever inputs information into the system actually signs it, which is the third part of the third solution to the third problem. So we should go to the next slide. How can we trust? If you remember, I indicated problem 3 being trust. Well, there's two parts to trust. One is if you're going to unleash an LLM, which I have nothing against, it's a beautiful technology, very empowering, but it's statistical. So it can make mistakes, it can hallucinate, it can go down the wrong path, depending on the complexity of the task, depending on the budget, depending on how full its context is. I don't think we're there to let it run in enterprise environments just as it is. but it's very powerful. On the other hand, what we know is, and this is this neural intelligence, right? What we do know for many years is symbolic AI, which is really knowledge graphs in one sort of embodiment. And that's where we are in the realm of rules. So logic-based reasoning, we can create through ontologies, and we can basically ensure that certain methods are executed, and there's nothing statistical about it. It's all rule-based. Therefore, when you build digital twins or the decision support systems, you can embed those rules inside, and you can essentially trust that there won't be a hallucination if you're applying the right technology here. And that's something that we do with the digital twins in the DMaaST project. With that, every fact that is introduced into the system is signed by a public key of the one who is inserting it, the one who's running the node where the data originates. So essentially, for every information, we have some sort of a verifiable credential-like knowledge asset. It is signed, it is hashed on a blockchain, and for that reason, you can always assert provenance, who created it, when, and what time, and you can assert integrity, that it hasn't been changed. So ultimately, this is where we get memory we can trust, and we can also trust the reasoning that's built on top of it. And that's why these digital twins are much more reliable, and that's why we're piloting them through the DMaaST project. Next slide, please. So what happens now in our original scenario? Well, we had the scenario where your supplier is out, you don't know where to start, and now you have a bunch of information organized in a graph with a cognitive digital twin, structuring it so that you can interact with it with your agent, and the agent runs a query, and in a matter of minutes, you basically get to a very, very solid information, maybe not the entirety of the information, but definitely cutting down the whole process from days or weeks to minutes, if the system is structured well, which is, again, part of the DMaaST project. And the ambition here is to make this delay disappear, ultimately make this supply chain, if you will, autonomous. So that's something that we're building towards. We also have two partners in the manufacturing space, Kamstrup and JPB, who have been very, very helpful and who are looking to build these systems into their daily work. So it's been very, very important to actually test all this. That sounds really nice in theory, but when you try it in the real world, it actually gets messy. And that's where the most exciting part, at least for me, is. The next slide, please. This is just one illustration of how this looks like. It's actually called context graphs on the DKG. So on the right, you can see two different sources, the purple and the blue, actually combining information into the same graph, making those connections and allowing agents, such as the one that you can see on the left, to basically make conclusions and traverse this graph. So this graph is basically shared memory. It's kind of like a shared brain, where you can unleash agents or more traditional services that can actually traverse and perform essentially graph RAG, a form of graph RAG, but done in a decentralized way, which is why we call it DRAG. It's our special flavor of graph RAG. Next slide, please. So ultimately, where do we get? We get to a point where we can resource capacity, and manufacturing as a service is something that is very close to the heart of the DMaaST project. You can also see it by the name. So the idea being that we can discover and trust who can build what across the network. We can absorb demand swings, replan, get live context, and based on that, live changes, and ultimately prove sustainability, because all of this information is traceable. So we can increase the sustainability and provide literally live digital product passports for all of these products that are part of this system. Next slide, please. Oh, yes. So this is, I'm going to conclude here. We're building the project on, like I said, OriginTrail, the decentralized knowledge graph, one of the technologies, the fundamental layer in the project, which we've been building for over a decade now. And actually, it's been applied across the world. So users such as the big US retailers, Walmart, Target, Home Depot, are using it for Trusted Factory Audit Exchange together with British Standards Institution. Swiss Railways is building on top of it for many years. pharmaceutical organizations, governments, and on the next slide, there's a few more examples, including the European Gymnastics Federation and several interesting European projects. I just wanted to point that out at the end because I'm also want to make a small call to anybody who's interested. This is open source, decentralized technology. You can benefit from it without even us, so you can take it, take all of the learnings and the improvements coming from the DMaaST project and start building on it. It's free. So thank you very much. I hope that was interesting. You can follow us and the progress of the project on the following links. And see you soon.
Branimir, thank you so much. This has been very inspiring. Obviously, I mean, I cannot be partial as we are partners in the DMaaST project, but what has been kind of interesting for me, because I have not been involved so much in the project, and to see how much of this kind of cognitive human and trust values you have embedded into development and into basically, which is basic kind of like, quite technical matters. I don't see any questions coming up in the Q&A, but what I would like, to maybe for all speakers to reflect on, I mean, all of our three projects here, they've EU funded. And, we have been discussing, a lot here in Brussels, all these issues about like, Europe being behind on AI and being behind, on the digital solutions. On the other side, Europe geographically is quite concentrated. So when it comes, for kind of manufacturing and the service and in industrial manufacturing as all, it's quite connected at the point. So I just wanted to see, what in your feeling, do you think like these sort of industrial AI or industrial application of these large language models, are they something, that we can put Europe on not maybe on the driving seat, but maybe on the level with kind of global developments? Is it something, that can really kind of enforce, competitive advantage or competitive equalness of Europe? And how do you see, this can kind of reflect on the general kind of European industrial performance? I would like Damir, if you can answer
Yes.
first, because I know, you have lots of experience very broadly on this.
Actually, I think you really put very on spot both question and I would say observation. And I have to say that European Commission start detecting this somewhere in 2019, and as of 2020, in various funded projects, they start to kind of ramp up exactly the approach in a sense, saying, okay, at certain technological level, maybe we are not that advanced, and okay, maybe we shouldn't compete on that. However, in certain parts, which were more B2B, more industrial oriented, we clearly have a lead. Let's focus on this. And actually, the projects that I mentioned, one of their purposes, and this is among other things why Europe is investing something like 60 million euros in it. It's not just to have a nice pilots and use cases, but it's exactly to demonstrate that these solutions that exist, that are advanced, that are very nice, can also be scaled up. And that's the point, scaling up, reusable, and this is basically something that can pretty much help. And then, of course, we will most likely in Europe very hardly have the lead on the LLMs from the purely B2C, let's say, point of view. However, on the business, and in particular, I would say more applied level, and in particular in manufacturing, but not only, also in flexibility and energy, and in other, let's say, and in the mobility, I think we still have a very, very good chance to have not only, I would say, most advanced solutions, but also take the lead. And this is really, I would say, only up to us how we will use this opportunity and how well I think the projects that we all do will keep promoting results, showing the value, and work with the broader community for the take-up. Because what is my feeling, and I will finish with this, is just that in many cases, a lot of good things comes from the projects. People are doing it. It's, it sounds great. And then after that, it's like, okay, I'm moving to the next project, which in a way is logical. But on the other hand, I think we are kind of all of us together not working enough to really kind of make sure that all good things that we do, and that was presented also today, is kind of taken up and moving forward, either in other projects or basically as much as possible to the market. Thanks.
Thank you, Mark. Thank you, Damir. I mean, this is kind of perfect reply in a way, because it sort of enforces, this networkness of the European projects and this kind of project and innovation ecosystem. Sebastian, do you have any thoughts on this sort of European competitive advantage or the leveling up?
Yes, definitely. I see a big advantage from the side of Europe, and especially as it was mentioned before, the B2B area, because from the point of, in order to, we know that in order to generate useful tools based on AI, you need the right data, you need curated data, you need to have data that you can trust. And I think that from that perspective, we have in Europe, in the B2B area, in the manufacturing area, a lot of data that we can use. What we need to understand, and some of that data is already structured, is already available. They have many projects that have been dealing with that. We have a lot of protocols in place that will allow us to liberate that kind of data. So what we need to bring together is that data with AI technologies and try to build the solutions that are relevant for Europe and for manufacturing. Of course, that will take a time, that will take some expertise. Perhaps the only case aspect where we will need to be careful is what we are basing our technology on. So if we are trying to reuse LLM models coming from OpenAI and things like that, we might have some dependencies in the future, but we have also solutions in Europe, European solutions that we can leverage. We have just heard in the previous talk about this kind of insight. So I think that we have an opportunity. It will take a little bit longer. The European Commission is investing. People are working on projects, are moving forward toward that. And just to finalize, also align with what Damir was mentioning, is that, we need to be more engaged into bringing what we are developing in projects into the industry. Otherwise, we will develop very nice technologies, we will have very great results, but the impact and the benefit of that will not be as big as we could imagine. So the opportunity is there. It's up to us to make it happen.
Thank you, Sebastian. Branimir, I've seen, you work, across so many different sectors and very different, from kind of like, the transport, to, was it, the sports. And I think it's interesting, to sort of see, because you definitely, from what we hear and what we know about the DMaaST, you embedded, some of this kind of European uncertainties, when it comes, to the AI, and application of the new technologies. How do you see the basically kind of like Europe doing in this brave new world?
I would like to echo and double down on what Damir and Sebastian basically said, and add one element to it, which is obviously competition is very strong, and one of the kind of the logical approaches is we should compete where we're strong, right? We should double down on our strengths. So if Europe doesn't have the biggest model, if we didn't build Fable for a reason, be that the US had more investment in building LLMs or whatever the reason, it might not be the thing to double down on, but something that we should double down on, in my opinion, is exactly the word you said, networkedness. So we're naturally a network continent. History taught us a lot about that, and that means we also are oriented towards making these networks work together. It's all about the data. I totally agree with Sebastian and Damir. That's all the value, and the US companies, particularly Chinese as well, they're basically capturing all the value from all of the data of everybody, including institutions and companies and individuals around the world. That's where they got powerful. So we should basically double down on European technologies that empower companies and individuals to use the data to their advantage to capture that value. OriginTrail is one of such technologies, and is basically, in my opinion, somewhere where we can actually be ahead. We don't have to just level up. I would even argue even though that might sound a little bit pretentious, that we already are ahead, and that we have, as the European startup ecosystem, the advantage because of the right principles. People in the world were complaining about GDPR. I think GDPR is a good thing. We should protect our privacy, and we should be able to own data about ourselves. And that's something that Europe has obviously brought forward. Without whatever the criticisms are, I think that's our DNA, and we should double down on it. So we should make that type of freedom and that type of sovereignty, but working as a network, something that outruns the Anthropics and the DeepSeeks of the world, and enables us to stay sovereign in it.
Thank you. I mean, this is great. I mean, because basically it totally enforces and it shows, that Europe has always been able to kind of move beyond, this kind of technology fetishism, where, we can kind of like just let the technology, run things themselves. So running, as you mentioned, GDPR, and other kind of elements, where we put the element of regulation into all of this and European natural industrial systems, I think that's very encouraging. We are already over the time. I would like to thank to our speakers, and I would like to thank to Olatz for organizing this. And please, join us on LinkedIn and follow up, and then, we'll be in touch. And thank you for all the participants, and thank you for your time. All the best. Thank you.